Bismillahirrahmanirrahim. The quote of the day is: if you are truthful, you will survive. If you lie, you shall perish. Today we will discuss about the measures of dispersion under the kind supervision of Professor Dr. Saira Afzal. Today we will learn about the definitions of dispersion, objectives of dispersion, range, interquartile range and deviation, standard deviation, variance, and coefficient of variance, and at the end there will be the recent updates and MCQs. By the end of this presentation, participants will be able to describe the basic measures of dispersion, their interpretation and application. Now, what is dispersion? Dispersion refers to variation of the items among themselves or around an average. Greater the variation among the different items of a series, the more will be the dispersion. As per Pauli, dispersion is a measure of the variation of the items. As in the bell-shaped diagram, you will see that this bell shape is more narrower than this one. So this means that the data is uh, much more dispersed in this wider bell shape. Now, objectives of measuring dispersion: to determine the reliability of an array, to compare the variability of two or more series, for facilitating the use of other statistical measures, and the basic of statistical quality control. Now, what are the properties of a good measure of a dispersion? It is easy to understand, simple to calculate, uniquely defined based on all observations, not affected by extreme observations, capable of further algebraic treatment. So there are two ways of measures of dispersion: absolute measures and relative measures. Absolute measures include range, quartile deviation, mean absolute deviation, and standard deviation, while the relative measures include coefficient of variation, coefficient of quartile deviation, and coefficient of mean deviation. The methods of measuring dispersion are range, interquartile range, mean deviation, standard deviation, and coefficient of variation. Now, what is range? It is the simplest measure of dispersion. It is defined as the difference between the largest and the smallest value in the series. And its formula is R is equal to L minus S, where R is the range, L denotes largest value in the dataset, and S denotes smallest value in the dataset. And coefficient of range is calculated the by subtracting the largest value by smallest value and by dividing the largest and smallest values. Now the procedure of calculating the range and coefficient of range. We will discuss it with the example. In the given example, find the range and coefficient of range for the following data. The data set includes 20, 35, 25, 30, and 15. First of all, we will arrange it in ascending order like 15, 20, 25, 30, and 35. Now the largest value is 35 and the smallest value is 15. So for range, we will subtract 35 minus 15. So our range will be 20. And to find the coefficient of range, we will add the largest and smallest values as we have already calculated the range. So their plus will yield uh, 50. So 20 over 50 is equal to 0.4. Now the merits and demerits of range. Its merits are: it is simple to understand, easy to calculate, and it is widely used in statistical quality control. While the demerits are: it cannot be calculated in open-ended distributions. The open-ended distributions are those when in the last or the smallest of the data, it is all we can see that in some data set it is written as more than 50 or more than or equal to 50 years. This type of data is open-ended distribution, and it's not based on all observations, and it is affected by simple fluctuations, and it is affected by extreme fluctuations. Interquartile range and quartile deviation. Interquartile range is the difference between the upper quartile and the lower quartile. Both of them are denoted by the Q3 and Q1 respectively. It covers dispersion of middle 50% of items of the series, and it is unaffected by the outliers. Similarly, it is denoted by interquartile range Q3 minus Q1. Quartile deviation is a half of the interquartile range. It is also called semi-interquartile range. Symbolically, it is denoted by Q3 minus Q1 divided by 2. Now the coefficient of quartile deviation. It is the relative measure of quartile deviation. It is measured by Q3 minus Q1 by Q3 plus Q1. Now the practice problem for the interquartile quartile deviation. Find the interquartile quartile deviation and coefficient of quartile deviation for this data set. First, we have to arrange it in ascending order. When we arrange these values in ascending order, we will get 15, 18, 20, 24, 27, and 28. Now, this 24 is the middle value. So we will ignore it, and then we will find the quartile 1 and quartile 2. So this will be our quartile 1 as in this figure. So its median will be 18, and for quartile 3, 28 will be our quartile 3. So for interquartile, we have to subtract quartile 3 from the quartile 1. So we will get 10. And for quartile deviation, we will divide this 10 by 2 to get the quartile deviation. And coefficient of quartile deviation uh, is is gained by subtracting the quartile 3 minus quartile 1 and by adding the quartile 3 with quartile 1. So we will get the value of 0.217 for this data set. Now the mean deviation. Mean deviation is the average of absolute values of deviation from the mean, median or mode is called the mean deviation, and its formula is summation x minus x bar over n, where x is the observation, x bar indicates the arithmetic mean, and it is calculated by summation x over n, adding all the observations by the total number of observations, and n is equal to total number of observations in the data set. We will try to understand it by an example. The example is the diastolic blood pressure of 10 individuals are as follows: 83, 75, 81, 79, 71, 95, 75, 77, 84, and 90. And these observations are given in this table. Then the next step is to find the arithmetic mean. So for finding the arithmetic mean, we need summation x, that is the sum of total observations. And in this example, its summation x is 810. Then we have to find the arithmetic mean. For finding the arithmetic mean, we will divide the sum of total number of observations by the total number of observations. So the sum of total number of observations is 810 and the total number of observations are 10. So we will get the arithmetic mean of 81. Then we have to find the difference between the observation and the arithmetic mean for all the observations. So here are their differences. Then the next step is we will add all these differences, and in this example we will get a sum of 56. No, in the last step we will divide this sum differences by the total number of observations. So we will get the value. So we will get the value of 5.6. So the mean deviation is 5.6. Now the merits and demerits of mean deviation. Its merits are it is simple, based on all values, and less affected of by the extreme values. Demerits are it is inaccurate, not capable of algebraic treatment, and it is unreliable. Now the standard deviation. It is the most important and widely used measure of dispersion. It is first used by Carl Pearson in 1983. It is also called root mean square deviation. It is defined as the square root of the arithmetic mean of the squares of the deviation of the values taken from the mean, and it is denoted by the sigma sign. Here it is formula: sigma is equal to square root summation x minus summation x minus mu whole square divided by n, where capital N denotes the size of the population or the total number of individuals in the population, and mu indicates the population mean, and xi indicates uh, uh, the observation of a single population. There are the different formulas for the different kinds of measurements. For population standard deviation, the formula is the same. For the sample standard deviation, we will take this mu is replaced by x bar. X bar indicates the sample mean, and in the denominator there will be n minus 1. It means that the total number of observations are subtracted by 1, and the sample variance is the square of the standard deviation, as it is indicated by s square. And if we take the square of this standard deviation, square will be cancelled by this square root. So this will be the formula of the sample variance. Now we will try to understand it by calculating an example. Here the historic blood pressure of the 10 individuals, which are as well follow: 83, 75, and so on, and find the mean deviation. First of all, we have to find the mean deviation. X bar is equal to arithmetic mean, and to find the arithmetic mean, we add all these values and divide it by the total number of observations, which comes out to be 81. Then we find the difference between the observation and the arithmetic mean, and the difference are given in the front of these observations. And then in the next step, we will take the square of these differences and then sum up. So their sum comes out to be 482. Then we put all these values in the formula, and as we get the summation x minus x bar whole square 482, and then we will divide it by the total number of observations minus 1, uh, as it is n minus 1. So it comes out to the standard deviation comes out to be 7.31. Now, why is standard deviation important? Things like heights of people in a particular population tend to roughly follow a normal distribution. Standard deviations are important here because the shape of a normal curve is determined by its mean and standard deviation. The mean tells you where the middle highest part of the curve should go. As in the middle, it is the mean in a normal distribution, and uh, the closest, the more smarter the or more narrower the curve is, the more of the data will be like close to the mean, or the dispersion will be least. Why is standard deviation important in science? Standard deviation tells us about the shape of our distribution, how close the individual data values are from the mean value, while the standard error tells us how close our sample mean is to the true mean of the overall population. Together, they help to provide a more complete picture than the mean alone can tell us. Now, who will interpret it? Interpret it? First of all, low standard deviation means data are clustered around the mean, and high standard deviation indicates that data are more spread out. A standard deviation close to zero indicates that data points are close to the mean. A high or low standard deviation indicates that data points are satisfactorily above or below the mean. Now, how is standard deviation used in real life? You can also use standard deviation to compare two sets of data. For example, a weather reporter is analyzing the high temperature forecasted for two different cities. Although standard deviation would show a reliable weather forecast. Now, the merits and demerits. Based on every item of the distribution, standard deviation is based on every item of the distribution, and it is possible to calculate the combined standard deviation for comparing the variability of two or more distribution. Coefficient of variation is considered to be the most appropriate. It is used most prominently. It is used most prominently in further statistical work, and its demerits are compared to others. It is difficult to compute. It gives more weight to extreme values and less to those which are near to them. Here is another example of calculating standard deviation. So the variance. Variance, it is another measure of dispersion. It is the square of the standard deviation, as I already told you that variance is the square of the standard deviation. The variance is a measure of reliability. It is calculated by taking the average of the square deviation from the mean. Variance tells you the degree of spread in your data set. The more spread the data, the larger the variance in relation to the mean. Variance is the average square deviations from the mean, while standard deviation is the square root of this number. Both measures reflect variability in a distribution, but their units differ. Standard deviation is expressed in the same units as the regional value. Why the standard deviation used more frequently than the variance? The answer is that the units of variance are squared, its units are meaningless. When calculating the population standard deviation, the sum of the square deviation is divided by n. Then the square of the result is taken. Now the coefficient of variation. It was developed by Carl Pearson. It is an important relative measure of dispersion. It is used in comparing the variability of the homogeneity, stability, uniformity, and consistency of two or more series. Higher the coefficient of variation, lesser the consistency. Actually, it is the ratio of the standard deviation to the mean and shows the extent of variability in a relation to the mean of the population. The higher the coefficient of variation, the greater the dispersion. Now here is the formula of the coefficient of variation. For the population coefficient of variation, its formula will be sigma over mu multiplied by 100, where sigma is the population standard deviation and mu is the population mean. And for sample coefficient of variation, its formula is standard deviation uh, over mu, or it can also be written as n, which indicates the sample mean multiplied by 100. Note the merits and demerits of coefficient of variation. The coefficient of variation is useful because the standard deviation of the data must always be understood in the context of mean of the data. The coefficient of variation is a unitless or a dimensionless number. So when comparing between data sets with different units or widely different means, one should choose the coefficient of variation for comparison instead of the standard deviation. While its disadvantages are when the mean value is near zero, the coefficient of variation is sensitive to small changes in the mean, limiting its useless. Now the time for recent updates. First article is taking metformin and cognitive function change in older patients with diabetes. Uh, I include these studies to indicate how these measures of dispersion can be used in research purpose and in our daily life. While there is nothing added newly in them, the aim of this study is we investigated the effects of metformin on cognitive function in a prospective cohort of older adults. Method is participants ages greater than or equal to 60 years were selected, and their Korean version for the consortium to establish a registry of Alzheimer's disease assessment, including mini mental state examination of daily life and activities of daily living were evaluated prospectively. Rapid deterioration of cognitive function was defined as annual change of test scores in the lowest quartile. Results. A total of 732 participants, mean age 76.7 plus minus 6.6 years, were followed for up for 2.9 years with the interquartile range of 1.0 to 1.7 years. A linear mixed model showed that the diabetes was associated with significant deterioration of verbal, delayed pre-recall, and cognition series. Among diabetes patients, metformin treatment was not only associated with changes in any Korean version of the consortium to establish a registry for the Alzheimer's disease assessment component or activities of daily living, however, rapid deterioration of mini mental state examination of verbal immediate recall scores are more frequently found in metformin taking group. The second article is effect of malnutrition on radiographic findings and mycobacteria burden in pulmonary tuberculosis. The background is the relationship between the malnutrition and tuberculosis severity is understood. We investigated the effect of malnutrition on radiological findings and mycobacterial burden. The results of 173 tuberculosis cases with chest X-ray data, 131 was male. The median age was 45 years within the range of 16 to 82 years, and 42 had malnutrition and 58 have moderate malnutrition. Median percentage of lung affected was 32% within the range of 0 to 95, and 132 had cavitation. This article uses various measures of dispersion to elaborate their data. Now the time for the MCQs. A person having dengue has tested his platelet count from four different laboratories. Their values are given in data. Find the range and the coefficient of range for the following data. These are easy values. You can easily calculate the range. Now these are their observation from the different labs. First lab indicates that the platelet count is of 30,000. Second indicates 36,000. Third 31,000. Fourth 40,000, and the last one is 35,000. So for calculating range, we need to have the largest value and the smallest value. In this data set, this is the largest value in the fourth row, 40,000, and the smallest value is 30,000. So if we subtract the largest value from the lowest value, this will be the 10,000. So E option will be our correct. And if we want to calculate the coefficient of range, we will divide this uh, uh, range with the addition of the largest and smallest value, which comes out to be 0.14. So E is our correct option. A newly anti-hypoglycemic drug has been given to seven poorly controlled fasting blood glucose individuals at night. Their fasting blood glucose levels are then tested in morning before the breakfast, which are listed in the table. Find the interquartile range and quartile deviation. These are again the easy calculations. You can find them. So for finding the interquartile range, we have to arrange first the data in the ascending order. As I have arranged it in the ascending order, then I will find the median, which is the which is the middle value. So in this data set, what is the middle value? Then I will find the quartile one, That will be the on the left side of the median, and the quartile 3 will be the on the second will be the median of the right side of the data set. So quartile 1 is 180 and quartile 3 is 280. So for interquartile range, I subtract quartile 3 with quartile 1, which comes out to be 100. And quartile deviation numerator will be the difference of the quartile 3 and quartile 1, and then divided by 2, which comes out to be 50. So Charlie is the correct option. Third MCQ. If in one of the groups of the premature infant, the maximum value for him hexosaminidase A was substituted with a much higher value, which of the given values remain unchanged, whether variance, range, standard deviation, median, or mean? Which value will remain unaffected? Which measures will remain affected by the extreme values? It will be the median. Median will be not be affected if the last values are substituted by the same value. Fourth MCQ is there are 50 individuals in the population and they have some same hemoglobin level, that is 14 gram. All the 50 individuals have 14 gram. All the 50 individuals have 40 gram per deciliter of hemoglobin. As there is no variability, the standard deviation will be whether 0, 1, 0, 0, 0, 1, plus 2 or minus 2. In this case, alpha 0 will be the correct option. As all the individuals, for 50 individuals have 40 gram, if we will take their x minus x bar, this will be 0. And if we do further calculation to calculate the standard deviation, the standard deviation will come out to be 0. So the 0 is the correct option. This indicate this is the kind of example which shows there is no variation in the data, as all the 50 individuals has 40 gram of per deciliter of hemoglobin. The standard deviation of set of 90 observation is 105. If the value of each observation is decreased by 9, then the new standard deviation of these observations would be remain the same, decrease to 96, decrease to 100, increase to 114, or increase to 110. If all the observations are decreased to 9, then 105 minus 9 equals to 96. All the no, it will be bravo, decreased to 96. All the observations have been changed. Seventh MCQ is the average cost of 100 pain medications was rupees 200 with the standard deviation of 40. Now, if price of each medication is increased to 20%, how will it affect the mean cost? Whether the mean cost will remain unchanged, the mean cost will be increased by 20%, the mean cost will be increased by 40%, the mean cost will be rupees 220, or the mean cost will be rupees 300. It's B, the mean cost will be increased by 20% as each value is increased to 20%. What does the sample standard deviation better estimate the population standard deviation? Whether by calculating the square root of the sample variance or by dividing n minus 1 instead of just n, by squaring the sample standard deviation by calculating the difference between each individual score and the mean of the sample, or by taking only small values. B is the correct option by dividing n minus 1, as in sample standard deviation the denominator is n minus 1. So it better estimates the standard deviation. Which one of these statistics is unaffected by outliers, whether mean, interquartile range, standard deviation, range, or mean deviation? Which will remain unaffected by the outlier? It is interquartile range. Interquartile range will remain unaffected by the outlier. Last MCQ is a sample of 10 students has been taken to find out how much time in minutes is required to complete a 20 MCQ based question paper. The time of each student consumed is given below and their mean is 19. Calculate the standard deviation. This is a calculation question. First observation is 20, second is 17, 18, 20, 17, 19, 21, 22, and 16 and 21. First of all, calculating the standard deviation, we will find their sum, and their sum comes out to be 190. And in the next step, we will find the mean. We will find its mean. For finding the mean, we will divide the sum of total number of observation by the total number of observations, comes out to be 19. And in the next step, we will find the difference of each of the observation. And in the next step, we will take the square of each difference of the observations. And in the last step, we will put these values in the formula as the summation x minus x bar whole square is equal to 32, and n is equal to 10, 10 minus 1 is equal to 9, and if these values are put in the formula, we will get the value of 1.87. So these will be the correct option. This is the key of my MCQ, and here is our YouTube channel by the name of Community Medicine King Edward Medical University. All of our presentations are uploaded here. You can visit this site by clicking this link, and thank you very much.
Thank you very much, Dr. West. Very nice presentation, and especially the slides that you have shown in recent advances. That was one of the best slide in today's session, where you have shown the standard deviation in age, as well as interquartile range and the IQRs. So this is one of a very good slide in order to understand that how we have to apply the different type of tests as well as summarization measures in the same data. As we have already been through different important tests, we know that some of the statistical significant tests are later produce the evidence for clinical practice. And one of this example is use of metformin. And as you have shown that when it is used for diabetes, it may affect the mini state examination even when the gender confounder is controlled. So the confounders are very important to control, and one of the way is to do important matching with age matched controls as well as with the group. And when there are continuous data, we have to apply the mean and standard deviation as you have shown in age group. While in the other group, as you have shown, that has interquartile range, the median interquartile range are the better summarization measures. So very nice presentation along with a very good example that you have shown in one of the research paper. Thank you very much, and Allah Hafiz.
Thank you very much, ma'am. Allah Hafiz.